So in this video, I'm going to explain again a Cauchy sequence. I have already uploaded a video on Cauchy sequence and I had proved a question based on Cauchy sequence in that video. And in this lesson also, I'm going to prove a question. This question I'm going to prove whether this is a Cauchy sequence or not. But before that, let's understand the definition of the Cauchy sequence. So a Cauchy sequence AN, this is a sequence, is called Cauchy sequence if corresponding to an arbitrary epsilon greater than 0 for all k belong to natural number n, there exists m belong to natural number n such that modulus of xm minus xn will be less than equal to 1 over k for all m n greater than equal to m. I have explained in my previous video, but let's understand here again what is this definition says. So let's take this sequence AN. Here this is the sequence, and if this is sequence AN, if you substitute 1, 2, 3 for n, so you will get this type of sequence. You will get this type of sequence, and it's saying a sequence AN is called Cauchy sequence if corresponding to an arbitrary epsilon greater than 0. First, understand what is epsilon. Epsilon is a number. This letter is from Greek letter, but this we use in mathematics, in real analysis and calculus. And the value of this epsilon is 0.01, 0.001, 0.001. So this type of number is called epsilon, and these numbers, value of epsilon will be nearly 0, approaching to 0. These numbers approach to 0. So all the numbers you can see nearly a 0. So what is the arbitrary means? This meaning of arbitrary means this can vary or change. Epsilon means this number, this can be this, epsilon can be this, epsilon can be this, or epsilon can be this. For all k belong to natural number, there exists m. So we are taking this A1, A2, A3, somewhere here m, the number. There exists m, which is also belong to n, somewhere here, and again going towards here, the sequence will be continue this way, and here somewhere here m, again continue the sequence, somewhere here n, again continue the sequence. So what is the meaning of this definition? A sequence AN is called Cauchy sequence if corresponding to an arbitrary epsilon greater than 0 for all k belong to natural number. There exists m. There exists. So this m, this value of m depend on this epsilon. So there exists a particular number here. There exists m, and after this particular number, we will choose any two number randomly. We will choose any two number, and we will find the modulus, difference of the modulus of this two number, like xm minus xn, and this difference of modulus of these two number after this particular number will be 1 over k. If we will get this one, it means this sequence is Cauchy sequence. And clearly you can see m and n greater than this m, this particular number. So here the meaning of this. So m and n will be greater than or equal to m. So this is the meaning of this Cauchy sequence. Understand this by the graph here. So if you take the graph, let's take m here and n here and n. I'll explain you by taking two graphs. So this one, this way, the point will be there, and after some particular point number, say that this is m. So after some particular point, the m and n difference will be very small, like depend on this epsilon 0.01. So this will be, the difference will be less than 1 over k. Our goal is to prove any sequence will be Cauchy sequence. If we will prove this difference of this two number, modulus of this difference of this two number will be 1 over k less than equal to, then we can say that that sequence is a Cauchy sequence. Also, you can understand Cauchy sequence. Okay, let's take this example 1 over n. If this is a sequence, so 1 over n means what is a1? A1 will be 1 over 1 equal to 1. A2 will be 1 over 2 equal to half. A3 will be 1 over 3. A4 will be 1 over 4. And this way the sequence continues. So here you can see that if 0 is here, let's take this one 1, 1, 2, 3, 4. And here the sequence 1 over n, this y-axis represent 1 over n. So here bigger number is 1. So let's take 1 here. Then this one will be half. Then this one will be 1 over 4. And here 1 over 3. So let's plot the point here. So if you substitute 1 for n, you got 1. So here this will be the point, then 2 and half, then 3, this is 1, 2, 3, 4, 3, 1 over 3 here, and 4, 1 over 4. So what the difference between these two number is bigger here. Then if you continue, the difference will be less. The difference will be less than, it will approach to n. So say that, let's take this is 4 is m. So after this, if you take randomly two numbers, the difference between these two number will be less than 1 over k. If we'll find this one, it means the sequence is Cauchy sequence. So based on this definition of Cauchy sequence, let's prove example this one and try to understand what is Cauchy sequence here. So what is our definition says? See here, epsilon, every epsilon greater than 0 for all k belong to natural number here. So here what we will do, here we will take, let k belong to natural number. So you can write it down, be an arbitrary natural number. Okay. Now what we have to prove? We have to prove xm, here xn given, the sequence here, this is the sequence given, xm minus xn, we need to prove this less than equal to 1 over k. Our goal is this one. Okay. Now what is xm? The sequence is xn is n over 2n plus 1. What is xm? In place of n, just substitute m. So 2m plus 1. Now find out here xm, write down xm minus xn equal to here xm. So we will write it down this one, modulus sign m over 2m plus 1 and then minus xn, n over 2n plus 1, give the modulus sign. Now try to find it out, calculate it inside, simplify it. Let's take the LCM, lowest common multiple or lowest common denominator is this one. Now we will find out here m multiplied by 2m plus 1 minus n multiplied by 2m plus 1, give the modulus sign. And then what we will get here, multiply this and open the bracket here, multiply this one and open the bracket, Be careful with minus sign here. So 2mn plus m minus 2mn minus n all over. Don't multiply in the denominator, leave it like this. 2m plus 1 minus, multiplied by 2n plus 1 and give the modular sign here. So this and this can be cancelled. M minus n we got, and 2m plus 1 multiplied by 2n plus 1. Give the modular sign. Now, what we will do, we will split it. So m, this will be m over 2m plus 1 multiplied by 2n plus 1 and minus, or you can say that plus minus n over 2m plus 1 multiplied by 2n plus 1 and modular sign on here. And what we are doing parallelly, I'm going to write it down this one, xm minus xn, so that you can understand. Xm minus xn, xm minus xn, xm minus xn. Okay. Now, if you see what is this equal to, this will be equal to, here we can write it down, less than equal to, we are taking this by triangle inequality. So here you can write it down using triangle inequality. I have uploaded a video on triangle inequality. You can check that video. You can find the description in this. You can find the link in description below. So I will write it down here. Modulus of m over 2m plus 1 and 2n plus 1 and plus mod sign on here, and then inside the modular sign minus n over 2m plus 1 and 2n plus 1 and give the modular sign here. So here you can write it down using triangle inequality. What is triangle inequality says? If mod of a plus b you have, it will be less than equal to mod of a plus mod of b. This is a triangle inequality and I used this one here. Now, this is less than, but this one is equal to, modular sign is there, so that this will be positive if you take out modular sign. So m over 2m plus 1 multiplied by 2n plus 1, then plus n over 2m plus 1 multiplied by 2n plus 1. Okay. Now we got here this one. And what is our goal? Our goal is here to make this all together, this one less than 1 over k. So our goal is to make this less than or equal to 1 over k. This is our goal. Okay. So our goal is this, and we are proving for this one. Now, what we will see here. Now I will do it here. Let's understand. I'm going to write it again here. We are doing now. Can we write this way? M over 2m plus 1 and then I'm going to write not 2m. I'm going to write here m over 2n plus 1 and 1 over 2m plus 1. This is the same thing, but I wrote it differently. Plus here I'm going to write it down n over, or you can write it down here m o no, I did mistake here. So here m over 2m plus 1 and 1 over 2n plus 1. Then here we will take n over 2n plus 1 and 1 over 2m plus 1. Okay. Now we need to make this is less than equal to k. This is our goal. This is less than equal to k. But to prove Cauchy sequence, we can see what we can remove from here. If you substitute m equal to c, m over 2m plus 1. If you substitute m equal to 1, 2, 3, 4, whatever number, it will always be less than half. This will be m over 2m plus 1 will be less than half, and n over 2n plus 1 will be less than half always. So substitute, try to check 1 over 2 plus 3. So 1 over 3, which will be less than half. If you substitute 2 here, so 2 over 5. 2 over 5 will be less than also half. Okay, so if you go to more higher number, it will be again less than 1 over 4. It will be nearly 0 point something. So we can remove this from here. Okay, so we can remove this from here as, so you can write it down here, xm minus xn is equal to 1 over 2n plus 1 plus 1 over 2m plus 1. You can write it down as m over 2m plus 1 will be less than half, or if you go to put higher number, it will be nearly 0. So no need to, not 0. If you think that 0, it will be 0, not 0, nearly 0. And 1 over 2n plus 1 as well less than half. Okay, so we can remove it. Now we have to, now here, now our goal is to prove always less than equal to 1 over k. Our goal is to prove Cauchy sequence. So we have to choose m and n large enough. As you understood the Cauchy sequence, here is our the particular number m, which I explained you in the definition. Go to the sequence. Here is m and here is n. So we have to choose m and n large enough so that this both will be less than equal to 1 over k. So you can write it down. We have to choose m and n large enough so that we can make 1 over 2n plus 1 plus 1 over 2m plus 1 less than equal to 1 over k. This should be our goal. Okay. If this will be here, then we can prove that this is Cauchy sequence. So now our goal is to add these two fraction to get 1 over k. So how you will add these two fraction? So we have to take 1 over 2n plus 1 less than 1 over 2k. But here you can ask I'm sure you're thinking why you take 2k here. So if you add 1 over 2k plus 1 over 2k, add this together, take LCM 2k. So 1 plus 1 on the top in the numerator. So 2 over 2k, this 2 cancel. So you will get 1 over k. That's why I took this one particular fraction less than 1 over 2k. Okay. Now here, what I will do here, I will cross multiply. So as you can see in the definition here, in the definition, m, small m and n greater than equal to particular that number m. So see the definition here. So small m and n So here in the definition here, m and n greater than equal to that particular m. Okay, so this one I'm going to do it here. Let's take 1 over 2n plus 1 less than 1 over 2k and 1 over 2m plus 1 less than 1 over 2k, or you can write it down less than or equal to. Okay, less than or equal to, less than or equal to. So take it less than 1 over 2k first, and then now here I'm going to cross multiply, do cross multiply. So 2n plus 1 will be less than 2k. Okay, now 2n is less than no, I did mistake here. We are multiplying 2n plus 1, so this one will be here. So multiply this way. So 2k will come over here, 2k less than 2n plus 1. So we can write it down here, 2n plus 1 is greater than 2k. This is greater than 2k. So 2n is greater than 2k minus 1. So n is greater than 2k minus 1 over 2. This you remember, I'll explain you now. Same here, I will do it here. So 2k is less than 2m plus 1. So write down 2m plus 1 greater than 2k. So 2m greater than 2k minus 1, m greater than 2k minus 1 over 2. So remember this thing as well here. So what is the meaning here? This is this m and n. So in the definition, m and n greater than equal to m here. Okay. So we have given here m and greater than equal to m, either greater than or equal to m. So we can write it down this one, m equal to. So m and both are greater than or equal to. So this particular number in the sequence m equal to 2k minus 1 over 2. So if you remember the sequence here, I explain you this particular number m is here. So this is the number here, 2k minus 1 over 2. After this, we are going to choose m and n. Okay. So this m is either less than or equal to. Okay. Now here, so now we are little bit away. So therefore, what we will take here. So let's remove it here, this thing. Now take this one, xm minus xn modulus sign is what we had here, 1 over 2n plus 1 plus 1 over 2m plus 1 here. From here, this one, okay, this one, I have taken this one here. Okay. So equals to what I have taken? This is parallelly write it down, xm minus xn is, we have taken 1 over 2k plus 1 over 2k. So xm minus xn is equal to, take 2k, 1 plus 1. So our goal is to prove this less than. So we are going to we have taken this one and we are going to, don't write it down, this one here now. So just write it down, 1 over 2n plus 1 plus 1 over 2m plus 1 will be, our goal is to prove less than 1 over k. Okay, so xm now you can write it down, xm minus xn will be less than equal to 1 over this one, 1 over 2n plus 1 plus 1 over 2m plus 1 will be less than equal to 1 over k. So write down here 2k plus 1 over 2k, 2k, 1 plus 1, it will be 2 over 2k, 2 cancel. So you can write it down this one. So now we have proved here xm minus xn will be less than equal to 1 over k for all m n greater than equal to m. So which proves xn is a Cauchy sequence.